Welcome to the Deep Dive. Today, we are strapping in for, well, a high-speed but really detailed tour of the emerging tech landscape for 2025. And look, this isn't just about slightly faster language models. It's really about autonomous AI agents starting to take control. We're talking complex, multi-step workflows. And crucially, what that fundamental shift means for pretty much any business that relies on, being visible online.
That's exactly right. Our mission today really is to connect three huge shifts that are all happening at the same time. We've pulled together insights from some very forward-looking reports. JP Morgan's Emerging Technology Trends for 2025 is a key one. And we've woven that together with, specialized knowledge on entity SEO and this new thing, Generative Engine Optimization. And the picture that emerges, well, it's one of total transformation. Honestly.
Okay, so the first pillar you mentioned is this agentic revolution. AI shifting from like a helpful assistant suggesting code or maybe drafting emails.
Yeah, the co-pilot idea.
Right, the co-pilot. Shifting from that to an autonomous system, one that's capable of multi-step decisions, actually executing tasks, maybe even managing financial transactions without a human stepping in. We're talking about systems that operate, I guess, essentially as digital employees.
Pretty much, yeah. Digital employees or maybe digital agents. And the second pillar, which kind of holds up the first, is the need for this massive overhaul in data and compute infrastructure. We're seeing the end of traditional scaling laws, just making models bigger, and instead the rise of reasoning models and these multi-agent systems. The very foundation of AI is changing, forcing smarter, more efficient computation.
Right. And then finally, these two things coming together. That leads to the third point, which sounds like maybe the most existential threat for brands, the collapse of traditional SEO. Because if these autonomous agents are generating the answers for consumers and those answers are just summaries with maybe a few citations, how do you get seen? So the core mission today is understanding why you really need to stop thinking keywords, keywords, keywords.
Yeah, that's yesterday's game.
And start building your brand as a clear, uniquely identifiable digital entity. You're saying this is an irreversible shift, right? And we need to get into the mechanics of that change.
Absolutely irreversible. We're moving from a world where visibility meant, matching the text strings people typed in, to a world where autonomous agents and LLMs connect concepts, understand things, and perform actions on your behalf. Every single trend we discuss today, from how models scale to agents handling money, it's all driven by this agentic evolution.
Okay, let's unpack this then. Starting where these trends really show up first. Innovative products and experiences. The goal across the board, looking at the research, seems to be creating frictionless interactions. And that applies both to consumers, obviously, but also to, the hundreds of thousands of employees inside large companies. That 320,000 number comes up a lot.
It does. It represents that enterprise scale.
Right. And their daily tasks are about to be automated. And the core concept making this happen is the Agent Operating System, or Agent OS. A framework built to execute these complex multi-step tasks autonomously.
Yeah, and the Agent OS, it's not just one giant model doing everything. Think of it more like the intelligent glue.
Yeah.
It plans, it delegates work, it monitors progress, it corrects mistakes. And the immediate impact of this system is, well, a complete upheaval in how content gets created and how internal training happens, mainly through multimodal models.
Okay, multimodal. We've heard that term before, but what does that transition really unlock for, say, a big company? Traditionally, AI models were sort of single-minded, right? Just text or just images or just voice.
Exactly, single data. Multimodal models, though, they combine and interpret diverse sources, images, text, video, voice, all at the same time, which mirrors how humans actually process information. It's messy, it's fluid, and this capability instantly transforms the enterprise content supply chain. It moves it away from static documents towards dynamic media.
Okay, so let's take an example. That, massive internal compliance report that nobody wants to read.
A 100-page PDF.
Exactly. So instead of employees having to slog through that, an autonomous multimodal agent can just ingest the report and instantly repurpose it, like generate short explainer videos specific to different regions.
Precisely. Or extract key quotes for an internal podcast series. Or create personalized interactive learning modules tailored to what an individual employee doesn't know yet.
Wow. So the boost for learning and development L&D, that sounds huge. Traditional L&D is often pretty static, right? One size fits all.
Totally static and generalized. But with multimodal models and these AI avatar coaches, the training material becomes really personal and interactive. The system can watch an employee try a task, see exactly where they struggle, which concept tripped them up, and then instantly generate a short, focused video. maybe featuring a realistic, full-sized AI avatar explaining just that one concept.
And the market perspective, the research says the big tech players are pushing hard on this. Hyperrealism and personalization are the differentiators.
That's the race. Enhancing video output, duration, resolution, making sure these personalized, realistic avatars who are essentially representing the company are absolutely flawless because any little glitch, any quality issue, it just erodes trust instantly. And the real win is the ability to quickly, cheaply update all this content, the avatars, the videos when something changes like a new policy. That's massive time savings.
Okay, moving to the second major area you mentioned, the evolution of voice AI agents. This is something everyone's probably felt pain with, calling a big company.
Oh, yeah. Getting stuck in that old clunky IVR,
Yeah.
the interactive voice response system.
The one where you're yelling representative into the phone after pressing 1 for sales, 2 for support.
Or repeating the same phrase 3 times, hoping it finally understands you.
Yeah.
It's incredibly frustrating and inefficient.
So what's the technical shift? How are they getting better?
Well, the old way involved stitching together 3 separate things. ASR, automatic speech recognition, to turn your speech into text. Then NLU, natural language understanding, to figure out what you meant. And finally, TTS, text-to-speech, to generate the spoken response.
Like a chain. And if one link broke.
The whole interaction failed.
Yeah.
Exactly. Now, the industry is moving toward unified speech-to-speech models. The model takes the audio in and directly generates the audio out.
Okay, so what's the functional improvement there? Why is that better?
It means the system can generate speech with the right pace, the right emotional tone, rhythm, context, because it's not stopping to translate back and forth between text. These sophisticated voice AI agents can now automate much more complex stuff, accessing customer data via APIs to handle account updates, answering detailed questions, intelligently routing really complex calls. The efficiency gains in contact centers are just dramatic.
And the market projections you mentioned back this up. Huge growth expected.
Massive growth. The AI voice generator market is projected to surge from, $3 billion in 2024 up to maybe $20.4 billion by 2030, driven by demand in retail, healthcare, automotive, you name it. But what's really interesting here is the emergence of emotional AI.
Emotional AI. How reliable is that today? And how does it actually, integrate into the customer experience? Is it just detecting keywords for angry?
It's still emerging, definitely not perfect, but the goal is critical. It's about understanding the user's tone, anger, frustration, confusion by analyzing pitch, volume, rhythm anomalies. So while we're not at perfect empathy yet, it lets the agent shift its strategy in real time. If it detects extreme frustration, maybe it tries to de-escalate immediately. Or it offers to transfer to a human much sooner. Or maybe it just simplifies its own language. This capability is absolutely key if you want to deliver on that promise of human-like interaction rather than just, faster robot answers.
Right. That ability to interpret emotion and context seems like the bridge to the next category you outlined, which sounds, pretty transformative. Agentic financial transactions. This is where AI agents stop just being helpful assistants and become, autonomous commercial actors.
Yeah, this is where it gets really interesting and frankly quite complex. We are talking about agent-to-agent workflows managing and executing financial transactions end-to-end. For consumers, think about autonomous agents constantly scanning the market to optimize your utility rates.
Yeah.
Or managing all your recurring subscription payments. Or handling complex travel bookings with multiple flights and hotels. Or even autonomously managing the returns process for that gift you got online that wasn't quite right.
Wow, so the agent shifts from being just a productivity tool to being like an economic engine acting on your behalf. What about on the business side?
The business applications are potentially even more profound. Imagine AI agents automatically tracking market volatility for raw materials and negotiating supplier pricing in real time, obviously within predefined limits or guardrails set by humans. They could manage financial portfolios, handle invoicing and payments automatically, execute trades based on incredibly complex algorithms and risk profiles. This really requires the industry to build out a robust global financial infrastructure that enables this kind of autonomous commerce agents making and receiving payments instantly across borders without needing a human to click approve.
Okay, the potential efficiency gain there is obvious, but this level of autonomy, it carries immense risk, doesn't it? What if an agent makes a bad trade or commits the business to a terrible contract? Who's liable?
That is the absolute core challenge, and it's why this innovation demands serious regulatory attention and technological oversight. As these agents get more capable, they're trusted with activities that have real-world economic impact. Big impact. So regulators are focusing hard on requiring robust controls. Things like non-repudiation, meaning every single action an agent takes is logged, auditable, and can be traced back to a human-defined policy or account holder. We need strong guardrails to ensure compliance with existing regulations like KYC, Know Your Customer, and AML, anti-money laundering, even when the customer initiating an action is an AI agent. The risk is definitely high, but the potential efficiency gains are just too massive to ignore.
Okay, before we pivot to the infrastructure powering all this, let's quickly touch on a key hardware piece. On-device AI. Because for a lot of applications, especially ones involving sensitive data or needing speed, relying only on giant cloud data centers, it's too slow, maybe too risky.
It's exactly right. On-device AI tackles this head-on by embedding sophisticated AI capabilities directly onto our personal devices, smartphones, laptops, IoT gadgets using specialized AI chips, often called NPUs, neural processing units.
And the benefits for the user seem pretty immediate and compelling. First, speed, right. Processing locally cuts down cloud latency, near instant responses.
Yep. Second, much stronger privacy. Sensitive stuff like your biometric data, maybe personal financial details, it stays on your device. That builds huge user trust. And third, offline functionality.
Hmm.
You can still use sophisticated AI features even if you don't have a constant internet connection.
And this allows for those really integrated applications, using frameworks like App Intents for voice commands or automatic actions.
That's the idea. Things deeply woven into your daily life. For instance, an agent analyzing your habits and, say, automatically ordering your usual morning coffee at the same time every day, all processed locally without sending your personal routine data off to some remote server.
There are some aggressive growth projections for this market, too, reaching potentially over $100 billion by 2031. Does this mean we're heading towards, like, paying for compute time on our own phones, or are the device makers just eating that NPU cost?
That's a really good question. Right now, the consensus seems to be that manufacturers are largely absorbing that cost. Why? To create a stickier, superior ecosystem. By putting these powerful NPUs in, they create a device that can run specialized, high-demand apps like real-time video editing or truly private local AI assistants that competitors without that specialized hardware simply can't match. It becomes a key selling point, a differentiator, and it drives that valuable ecosystem lock-in. That's arguably worth more long-term than trying to nickel and dime users for local compute cycles.
Okay, that makes sense. So we have these incredibly capable agents doing amazing things, increasingly on our devices, but none of it works without the back end, right? Let's pivot now to the foundation, delivering AI at scale, the data and the infrastructure.
Right, because none of this sophisticated agent stuff happens in a vacuum. It requires a massive overhaul of the data and infrastructure supporting it. And the core issue driving this overhaul is that the traditional ways models learn and run, well, they're hitting some serious constraints. It's forcing a fundamental shift in how AI gets developed.
Okay. Traditionally, model providers followed those scaling laws we hear about. Performance improved if you scaled up three things: model size, more parameters, training data volume, just feed it more stuff, and the compute power used for training. But we're hitting roadblocks now. Compute scarcity is one, but you mentioned something more fundamental: the scarcity of quality training data.
Exactly. We are genuinely approaching what some key figures in the industry are calling peak data.
Hmm.
Elise Sutskever, OpenAI's co-founder, had a very direct quote on this. He said something like, "Pre-training as we know it will unquestionably end. We've achieved peak data and there'll be no more. We have to deal with the data that we have."
Wow, peak data has been reached. That changes everything, doesn't it? If you can't just improve performance by scraping more and more public data from the web. So if throwing more raw data at the problem isn't the answer anymore, where does the extra intelligence come from?
The scaling laws themselves are evolving. The new focus is shifting dramatically towards inference time compute. This is a major paradigm shift, away from just the size of the model at training time and towards how much processing power you use while the model is generating a response during inference.
Okay, so if the knowledge isn't perfectly baked in during pre-training, how does the model figure things out when I ask it a complex question?
Instead of trying to cram all possible knowledge into the model during that initial, incredibly expensive pre-training phase, models are now being optimized to use computation time during inference to essentially think step by step. They use the compute allocated for your query to reason, to check their work, maybe correct themselves, and refine their approach. This led directly to the development of what we call reasoning models.
And the key technique there is the chain of thought approach. We hear that term a lot. Can you break down how that internal thinking process actually works? How does it improve performance?
Sure. Chain of thought is basically about making the model show its work, externally or internally. When you give it a complex query, especially one needing multiple logical steps, think math problems, coding tasks, the model doesn't just leap to the final answer. It breaks the problem down into smaller sequential steps. It generates this kind of internal monologue or scratchpad of reasoning. And crucially, this reasoning process might involve exploring multiple possible paths to the solution, almost like a tree search. If one path hits a dead end or an error, the reasoning model can actually backtrack, self-correct, revisit an earlier step, and try a different strategy.
Ah, okay. So the output isn't just the answer, it's potentially a verifiable, logical path to that answer. And that ability to backtrack and correct gives it the power to tackle harder problems.
Exactly. Problems that would have been impossible if it just had to generate the answer linearly, in one shot. We saw this really clearly with OpenAI's reasoning model, O1. That ability to use more inference time for reflection and correction has quickly become the industry standard approach. Google DeepMind's research points the same way. They found that scaling up compute at test time or inference time can be more effective for complex tasks than just making the model bigger and bigger, especially once models hit a certain size.
And there are economic implications too, right? If high-quality data is scarce and massive training compute is super expensive, smaller players can't just outspend the giants on training. They have to focus on making the models they do have reason more efficiently.
Precisely. If we're at peak data, we need ways to generate new, high-quality data. So to overcome that scarcity, the industry is turning really aggressively towards synthetic data, particularly in the post-training optimization phase.
Right, because getting enough diverse, high-quality, human-curated data for that fine-tuning stage, the SFT, is hard and expensive. So the models are essentially generating their own training examples now. But how do you make sure that synthetic data isn't just, well, garbage?
That's the clever part, linking it back to the reasoning models we just discussed. Providers use these superior reasoning models to generate many, many possible step-by-step solutions, chains of thought for a given problem, thousands of attempts. Then, they often use other models or evaluation techniques to rigorously assess all those generated paths and select only the optimal ones, the most logical, verifiable, error-free ways to get to the right answer.
So you're not just creating synthetic answers, you're creating synthetic reasoning processes, synthetic intelligence almost.
That's a great way to put it. Synthetic intelligence pathways. These optimal reasoning paths are then packaged up as high-quality synthetic data and used for that supervised fine-tuning. Training on these proven logical sequences dramatically boosts the model's ability to think and reason through tricky, verifiable tasks, advanced math, complex code generation, engineering problems. Gartner's forecasts really highlight how critical this is becoming. They predict something like 60% of the data used for AI and analytics projects this year will be synthetically generated.
Wow, 60%. Okay. Now, tying this back to the autonomous agents we started with, achieving that really complex stuff like managing finances or generating sophisticated content, that probably requires more than just one super efficient reasoning model working alone, right? It needs cooperation.
Exactly. Which brings us to the final big structural shift in the infrastructure layer.
Huh.
The move to multi-agent systems, MAS.
Okay, so MAS, what's the core idea there?
It's the natural evolution. Instead of one single monolithic agent trying to do everything, planning, using tools, executing the final task, you move to a system where the work is delegated. Think of it like a digital org chart. You have an orchestrator agent at the top. It understands the overall goal, breaks it down, and then delegates specific subtasks to specialized subagents who can work in parallel.
Let's walk through that research assessment example again, but focus on how the agents would interact in an MAS setup.
Okay, so the human gives the high-level task. Assess market entry risks for product X in country Y. The orchestrator agent receives this. First, it creates an execution plan. Step 1, research. It delegates this to a specialized researcher subagent. This researcher agent knows how to use tools like web search, maybe access internal proprietary knowledge bases. It gathers raw data and reports back its findings. Simultaneously, or perhaps right after, the orchestrator tasks a validator subagent. Its job is to take the researcher's findings, evaluate their quality, cross-reference them, check for contradictions, and basically provide feedback on accuracy and coherence.
And while those two are busy, maybe the orchestrator gets a writer subagent started on just structuring the final report outline.
Precisely. Then, once the research is validated, the writer subagent compiles the final report, incorporating that validated data and maybe feedback loops between agents. This MAS structure allows for much greater automation of complex, long-running workflows compared to a single agent trying to juggle everything. Gartner's prediction here is significant too. By 2028, they think about a third, 33% of all interactions with generative AI will involve these autonomous agents completing complex tasks in this way.
A third. That's a huge shift in how actual work gets done inside companies. But technically, managing this digital workforce must be complex. What are the big challenges for that orchestrator agent?
The main complexities revolve around communication and managing the shared state or context. Since you have multiple agents working in parallel, possibly asynchronously, the orchestrator needs sophisticated ways for them to share information efficiently, usually involving shared memory or caching systems. For example, if the researcher finds a critical piece of data, the validator and the writer need access to that instantly, without having to refetch or recalculate it themselves. Shared memory stops agents duplicating effort and keeps everyone working with the same up-to-date information.
And of course, when you have multiple autonomous agents potentially accessing sensitive company data, security and governance must be absolutely paramount.
Oh, absolutely critical. The system needs very granular access controls and secure APIs. You need to ensure, for instance, that the writer subagent only sees the final compiled summary it needs to write about, while the validator subagent might need access to the raw source data to verify it, but nothing else. Robust data security becomes mandatory the moment you move from single-purpose models to these complex, interdependent multi-agent systems interacting with enterprise resources.
Okay, so we've covered a lot of ground on how AI is changing service delivery, finance, the infrastructure, how models think. If AI is changing how services are delivered and how the underlying models work, it absolutely must be changing how those services and brands get found in the first place. Which brings us squarely to that search visibility paradigm shift. You're saying the old rules of SEO are basically collapsing.
They really are. This is effectively the death knell for traditional, purely keyword-focused optimization. And it's driven entirely by that agentic shift we talked about, the move from thinking about keywords to thinking about entities. For so long, getting found online was mostly a string-matching game. Did your web page contain the right combination of text that matched what a human typed into the search box?
Okay, let's really nail down that difference for everyone listening. What exactly is the difference between a keyword and an entity, especially from a machine's perspective?
Sure. A keyword is just promptly. Well, it's a string of text, data points. An entity, on the other hand, is a uniquely identifiable, distinct thing or concept. It could be a person, a specific company, a product model number, a city, an abstract idea like democracy. Crucially, the machine needs to understand what that text string represents in the real world. So the string apple doesn't mean the fruit, the tech company, Apple Records. An entity resolves that ambiguity.
Right. And this is the core job of Google's Knowledge Graph, which they introduced way back in 2012, wasn't it? It's their huge database of these interconnected entities and facts.
Exactly. It shifted search from just matching strings to matching things. The Knowledge Graph tracks relationships. Who founded this company? What products does it make? What concepts is it related to? Where is it located? When search engines like Google can confidently identify the entity your content is actually about, that unlocks maximum visibility potential. Entities are the foundation for all those prominent search features we see. The knowledge panels on the side, the rich snippets with stars or prices, the featured snippets at the top, and those really important people. Also ask PAA boxes. If Google can't confidently map your brand or your product to a specific high-confidence entity in its graph, your content is basically stuck down in the list of plain blue links, which are rapidly losing clicks and relevance.
So this focus on entities is the bedrock of Generative Engine Optimization, or GEO, which is the optimization strategy we need for AI-powered search, like Google's SGE Search Generative Experience or Bing Copilot. And you mentioned the stakes here are existential for businesses built on organic traffic?
They absolutely are. Gartner's forecasting, again, that traditional search engine volume might drop by 25% by 2026, just as people shift to using AI chatbots and these AI-driven search results more often. But the really alarming number is their prediction that actual organic search traffic clicking through to websites could decrease by 50% or even more by 2028.
50%. That's an apocalyptic number for a lot of online businesses. Does the source material give any more detail there? Is that mainly for informational searches, or does it hit e-commerce brands hard too?
It definitely affects all areas, but it's likely most pronounced initially for those informational queries, the what is, how to type searches, and maybe middle of funnel comparisons. The reason the prediction is so stark is because the AI summary, the SGE answer box, is designed to be the final answer. If you're searching for, say, a recipe or a definition or how to fix a basic coding bug, the generative engine aims to give you that answer directly, right there, which removes the need to click through to 10 different websites. The AI agents are essentially automating the research phase for the user. The search engines want to keep the user within that generative experience, which naturally means fewer clicks going out to traditional organic results.
Okay, so the goal of GEO is fundamentally different from old school SEO. It's not about ranking #1 in the blue links anymore. It's about earning a citation inside that AI-generated summary box that appears right at the top, often above any traditional results.
That is the absolute crux of it. It becomes a winner-takes-all, or maybe winner-takes-most scenario. When SGE or Copilot constructs its answer, it typically pulls snippets of content from, on average, maybe 10 citation links. These are the sources it deems most relevant, authoritative, and importantly, well-structured for easy extraction. If your content doesn't make it into that list of 10 cited sources for a given query, you're effectively invisible to the user getting their answer from the AI, even if your page technically ranks, say, #3 in the list of links shown below the summary.
Being cited by the AI is the new #1. Okay, so let's get tactical. What are the specific how-tos? How do we actually optimize content for this kind of AI ingestion? We need to move beyond the theory.
Okay, the first principle, stressed heavily by experts at Microsoft, Google, and others, is extreme clarity through structure and snippability. AI agents, especially these reasoning models that need to verify information, they absolutely thrive on clearly marked, distinct blocks of information. They need to be able to confidently lift a specific piece of text, a sentence, a paragraph, a list item, and use it as part of the answer or as a citation, without having to guess where one idea ends and another begins in a long, rambling wall of text.
Right, so that means practically use really descriptive H2 and H3 headings and stick rigorously to that idea of one core concept per section under a heading. You need to prioritize that block level structure so the AI can easily grab a complete self-contained thought.
Absolutely. It also means consciously structuring content into concise Q&A blocks where appropriate, using short, clearly formatted bulleted or numbered lists for steps, features, or comparisons, creating simple comparison tables, and, just as importantly, avoiding the technical traps that confuse AI ingest engines, things like huge paragraphs of dense text, hiding important content behind tabs, or click-to-reveal accordions, putting critical details only inside images without really descriptive alt text, or burying essential information in downloadable PDFs instead of having it directly on the HTML page. You have to make the core information immediately machine-readable.
Makes sense. Okay, second major tactic, leveraging schema markup. Most people might know schema for tagging things like product reviews or event dates, but for GEO, we need to think bigger, right? Entity-level schema.
Exactly. Schema markups are basically types like organization, person, product, FAQ page, how to acts like the structured DNA for your web page. It explicitly tells the AI systems, this block of text represents our company, or this page describes this specific person, or this is a step-by-step guide. It dramatically reduces ambiguity for the machine and strengthens the connection between your content and the concepts in the knowledge graph. But for GEO, probably the most powerful piece within schema is using properties like same-EAs.
Okay, the same ACE property, what does that actually do in practice? How does it help?
It's how you build verifiable authority and connect your corner of the web to the wider knowledge graph. If you use, say, organization schema on your About Us page, and within that schema you include same-EAs properties pointing to your official Wikipedia entry, your verified LinkedIn company page, maybe you're listing in a major business directory, like Crunchbase or Wikidata, you are essentially handing the AI high-confidence external signals that confirm, yes, this website for Acme Corp is the same entity as this well-known Acme Corp entity we already know about. It bridges your site to establish knowledge, reducing ambiguity and boosting perceived authority. It's the difference between just describing your content and actively linking your entity into the recognized ecosystem.
Got it. And this all ties into the ultimate goal, which is using entities to strengthen EEAT experience, expertise, authoritativeness, trustworthiness. For years, EAT felt a bit fuzzy, but entities make it more concrete.
It's no longer quite so nebulous. It becomes about entity correlation. If your brand is clearly defined as an entity, and structured data connects that entity to, say, verified founders with demonstrable experience, maybe through person schema linked via sommiers to their publications or profiles, or to published research papers or membership in reputable industry associations, then Google and other AI systems can much more confidently associate your brand entity with genuine authority and expertise in its field, This is absolutely critical in those YMYL, your money or your life sectors like finance and health.
And one final point from the source material on this, the importance of brand notability off your own website, unlinked mentions.
Yeah, this is really key for how LLMs learn. They identify statistical patterns across vast amounts of text. They learn to recognize when your brand name, even without a hyperlink, frequently appears alongside terms related to expertise or positive sentiment in highly authoritative external sources, think major news articles, respected industry reports, academic papers. If Acme Corp is consistently mentioned in the Wall Street Journal next to phrases like leading innovation in widget technology or cited as a verified source in a government report, those unlinked mentions become powerful training data. They teach the LLM that your brand entity is associated with authority and trustworthiness. So proactive reputation management isn't just about handling today's PR crisis. It's about strategically influencing the data landscape from which the next generation of AI models will learn about your brand's reputation tomorrow.
That's a powerful thought, shaping the AI's future understanding of you.
It really is. So just to summarize the overall trajectory we've mapped out here, the integration of these AI agents across finance, content creation, customer service, and the underlying compute infrastructure is happening, and it's completely irreversible. The ability of these systems to think more effectively using reasoning models and to cooperate using multi-agent systems, that really defines the next era of computing efficiency and automation.
And what this means for you, the listener, is pretty straightforward, if maybe a bit daunting. The digital world is fundamentally becoming agent first. If you want your brand, your service, your content to remain visible in this new reality, you absolutely have to stop relying solely on outdated keyword strategies. You need to actively define yourself, your brand, your products as clear, unambiguous, structured entities. And you need to use these sophisticated GEO tactics we discussed, structure, schema, authority building, to ensure that when an autonomous agent or a generative search engine looks for an answer in your domain, your well-structured, authoritative content is what earns that crucial citation in the AI answer box. Because increasingly, visibility equals existence in this emerging agentic economy.
Couldn't agree more. The stakes are incredibly high for visibility, for trust, even for financial autonomy, as agents take on more tasks. But there's one final, maybe slightly provocative thought that touches on a fundamental speed limit baked into this whole revolution. We've talked a lot about how seamless and human-like these conversational agents are becoming. Yet, the source material rightly points out that the conversational interface itself, talking or typing, is fundamentally slow.
Right. We think much, much faster than we can speak or type. The estimates vary, but maybe thought speed is somewhere between 1,000 to 3,000 words per minute equivalent, whereas speech is maybe 150 words per minute.
Exactly. Natural language, while it feels natural to us, is actually a pretty severe bottleneck for transferring information between a human brain and a machine. It's why we instinctively use gestures, shortcuts, slang, emojis. We're always trying to compress information transfer to keep up with the speed of our own thoughts.
So the provocative question is, if these AI agents are getting so good, so fast, poised to take over complex multi-step tasks like managing our finances or complex business operations, should we really accept the relatively slow, verbose conversational interface, talking or typing, as the ultimate long-term way we interact with them?
Or will the next true leap in creating that frictionless interaction be something even faster? A truly compressed form of input. You called it maybe the voice equivalent of a thumbs up. Perhaps leveraging advanced emotional AI, maybe biometrics, to infer our intent almost instantaneously.
Like a silent, immediate interface,
Mhm.
based on microexpressions, maybe subtle sounds, maybe even brain-computer interfaces eventually, something that finally allows the human brain's processing speed to keep pace with the hyper-efficient machine it's interacting with. That feels like the ultimate frontier of frictionlessness to think about.